The ideal gas law is the last gas law that we need to learn that is unique, that is for special cases involving ideal gases. And the unique thing about this equation, PV equals nRT, is that it includes the quantity, the amount of a gas in the equation. The combined gas law, P1 V1 over T1 equals P2 times V2 over T2, does not include the amount of gas. Let's see what I mean by that. So, in the ideal gas law, we have PV equals nRT. P stands for pressure. V stands for volume. T stands for temperature. And now we have two new variables that we have to explain. N stands for the number of moles. So this is the quantity, the number of moles of the gas present. And R is something called the ideal gas constant, meaning that it's a number. And we can round the ideal gas constant to 0.1. So anytime you use this equation, you'll plug in 0.1 for R. There's a few things that we have to know about the ideal gas law. Whenever we use pressure, the units have to be in ATM. Whenever we use temperature, the units have to be in Kelvin. And whenever we use volume, the units have to be in liters. The types of problems you'll have to solve involving the ideal gas law, you'll be given 3 of these variables, and you'll have to solve for the 4th. So let's look at an example. Number 1 says, a bottle filled with an ideal gas has a volume of 2 liters at 400 Kelvin and 2 ATM. How many moles of gas are in the bottle? So when I'm trying to decide what equation I need to use for this, I need to look for some keywords. It says a bottle is filled with an ideal gas. So that's a dead giveaway that I should be using the ideal gas law. Another way to check if you should be using the ideal gas law is, does the problem have to do with the quantity of gas, the amount? Well, it asks how many moles, and moles is the quantity, so I should be using the ideal gas law. Let's look at our givens. We have a volume of 2 liters, so that's V. We have 400 Kelvin, you got to know your units, Kelvin's for temperature, and ATM is for pressure. So I'm given P, T, and V. I got to plug those values in. So my pressure, 2 ATM, times my volume, 2 liters, equals my number of moles, I don't know yet. R is the ideal gas constant, is 0.1 no matter what gas you have or the amount you have, and the temperature, 400 Kelvin. So now I just have to solve for N. 2 times 2 on the left side is 4 equals N times, and the trick here, whenever you multiply by 0.1, all you have to do is move the decimal to the left 1 place. So 400 times 0.1 is the same thing as 40. So now to solve for N, I divide by 40, divide by 40. So 4 divided by 40 gives me 1 over 10. So N equals 1 over 10 moles. So if there is an ideal gas that has this pressure, temperature, and volume, there'd be 1/10 of a mole of that gas. Let's try another problem that we'll model together. Number 2 says 20 moles of hydrogen, an ideal gas, occupy 4 liters at 250 Kelvin. What is the pressure of this gas sample? So my unknown is pressure. Once again, let's look for some keywords. Ideal gas, and I've got moles, my quantity. So I'm going to be using the ideal gas law, PV equals nRT. So number of moles is N, 4 liters is volume, 250 Kelvin is temperature. So I plug in my values. Pressure is my unknown, so that's going to be left as P. Volume is 4 liters. N is 20. R is always 0.1. and T is 250. Once again, remember, if I multiply any number times 0.1, all I really have to do is move the decimal to the left. So 20 times 0.1, move the decimal once to the left. So this becomes 2 times 250 equals P times 4. Divide by 4 on both sides. So I get P equals 500 over 4, which equals 125. And now you got to check. It's asking for pressure. You have to know the units for pressure when you use the ideal gas law are always going to be ATM. So go ahead and try the next two problems by yourself for practice.